Dear students, Assalamu alaikum. It's my second lecture for F.Sc part 1 and the topic for discussion is mole and Avogadro number. Generally, when we measure physical properties, we use certain units. For small quantities, we use smaller units, and for expressing large quantities, we use very large units. Let us take an example. Let us suppose the length of pen is expressed in centimeters. The size of room is expressed in meters. The distance between cities is expressed in kilometers. The distance between sun and earth is expressed in light years. Similarly, when we come towards mass, as the size of the quantity increases, the unit also increases. For example, the mass of gold is expressed in milligrams or grams. The mass of sugar is expressed in kilograms. The mass of wood or coal is expressed in moles. The mass of steel is usually expressed in tons. It shows that as the size of the quantity increases, we use larger units. Same is the case with counting process. In ordinary life, in usual practice, in common life, we use different group names for different groups. For example, if we have a group of 12 similar things, then this group is called dozen. If we have a group of 20 similar things, then it is called score. And if we have a group of 144 similar things, then it is called gross. Now these groups, dozen, score and gross, they are known as the usual groups of counting, the groups which are generally used for counting. But these groups can only be used if we are counting macroscopic objects, very large objects which can be seen with the naked eye, like pencils, tables, chairs, etc. But these groups fail to count microscopic particles. We cannot count microscopic particles by using these common groups. Like they cannot be used for counting atoms, molecules, ions, or formula units. Now the question is, why these groups fail to count these particles? The reason is that these particles, the atoms, molecules, ions, or formula units, they are present in very large numbers. In a countless number, they are present in countless numbers. Let us suppose we draw a line with pen which is 1 centimeter long. Then this 1 centimeter long line contains 10 to the power 8 atoms of ink, or 10 crore atoms of ink are present in this line, which is a very large number. Consider how much atoms will be present in this whiteboard. We are unable to count them. We cannot express them with the help of these groups, which are very small groups. And we know the general trend, as the size of quantity increases, then we move towards larger units. So these units cannot be used for counting atoms, molecules, or ions. To count microscopic particles, a new unit was introduced, which is known as mole, and it is denoted by MOL, written as MOLE but denoted by, abbreviated by MOL. Now there are 7 units in the SI system. In the SI system, System International, there are 7 basic units. These are: unit of length is meter, unit of mass is kilogram denoted by kg, unit of time is second denoted by S, unit of temperature is Kelvin denoted by K, unit of current, 5th unit, is ampere, unit of light intensity is candela denoted by CD, and the unit of quantity of substance is mole. Denoted by MOL. So we can say that mole is one of the 7 basic units of the SI system, which is used for counting microscopic particles like atoms, molecules, ions or formula units. Now the question is, how we will define mole? What will be the definition of mole? There are 2 definitions. One is old definition and the other is modern definition. According to old concept, if we have carbon 12 grams of carbon 12, carbon has 3 isotopes, carbon 12, 13 and 14, and we have 12 grams of carbon 12. Let us suppose that this 12 gram of a piece of carbon 12, which is 12 gram, it contains some number of atoms, unknown number of atoms are present in this piece. Let us suppose X atoms of carbon are present in this piece of carbon. Now according to old concept, if we take other substances, for example, if we take iron, a piece of iron which contain atoms, which is made up of atoms, the elementary particles of iron are atoms. If we have some water in a beaker or in a glass, we have some water in a beaker or in a glass, this water consists of molecules. The elementary particles of water are molecules. And if we consider a third substance such as sodium chloride, now in this case the particles, constituent particles or elementary particles are formula units. According to old definition, the amount of any substance which contain as many elementary particles as there are atoms in 12 grams of carbon 12 is called 1 mole of that substance. Quantity of a substance which contain as many elementary particles as there are atoms in 12 grams of carbon 12. We have supposed that 12 gram of carbon 12 contain X atom. So according to definition, if we take a piece of iron which contain X atoms of iron, then it will be called 1 mole of iron. Similarly, if we take an amount of water which contain X molecules of water, then it will also be called 1 mole of water, because it contains the same number of molecules as are present atoms in 12 grams of carbon 12. It is 1 mole of water. Similarly, if we take a piece of sodium chloride which contain X formula units of NaCl, then it will be called 1 mole of NaCl. Now the question is, what is the number of atoms which are present in 12 grams of carbon 12? What is the value of X? There was a scientist whose name was Avogadro. He determined that X is equal to 6.022 into 10 to the power 23. It means that 12 gram of carbon 12 contains 6.022 10 to the power 23 atoms. And this number is called Avogadro's number. It is called Avogadro's number and is denoted by capital N or N subscript A. Na. It is denoted by N or Na. Now we move to a modern definition of mole. The modern definition is that a group of 6.022 into 10 to the power 23 elementary particles which means atoms, which may be atoms, molecules, ions or formula units of a substance. A group of 6.0 elementary particles of a substance is called mole. Now we come to examples of mole. According to modern definition, 1 mole of iron will contain 6.022 10 to the power 23 atoms of iron. 1 mole of water will contain 6.022 into 10 to the power 23 molecules of water, and 1 mole of NaCl will contain 6.022 into 10 to the power 23 formula units. Now we use another term which is called molar mass. What is meant by molar mass of a substance? Molar mass may be defined as the mass occupied by 1 mole of any substance. The mass occupied by 1 mole of any substance is called molar mass. Molar mass is equal to atomic weight, atomic mass expressed in grams. It is equal to molecular weight, molecular mass expressed in grams, or it is equal to formula mass expressed in grams. If a substance is made up of atoms and its atomic weight is known in atomic mass units, we express this mass in grams, then it will be called 1 mole of that atomic substance. If a substance is made up of molecules and we know its molecular weight, molecular mass in atomic mass unit, then we express it in grams and it will be called the molar mass of that molecular substance. Similarly, if a substance consists of formula units and we know its molecular weight in atomic mass unit and we express this formula weight in grams, then it will be called the molar mass of the substance. Now in this case, 1 mole of iron contains so much atoms. The atomic weight of iron is 56 atomic mass units, but its 1 mole will be equal to 56 grams per mole. The unit of molar mass is gram per mole. So it will have the atomic weight will be expressed in grams and it will become the molar mass of iron. The molecular weight of water is 18 atomic mass unit, 2 plus 16, 18. So 1 mole of water will be equal to the molar mass of water will be 18 grams per mole. Similarly, the molar mass of sodium chloride will be 23 plus 35.5, 58.5 grams per mole. So if we express the atomic weight or molecular weight or formula weight of any substance, it will be called the molar mass. Now the question is how we are going to calculate the number of moles of any substance. The number of moles of substance, calculation of moles, calculation of number of moles. There are 3 different equations which are used for calculating the number of moles. The first equation is that number of moles of any substance is equal to mass in grams divided by molar mass. Mathematically, we can write it N is equal to small m by capital M. Small m by capital M. Let us suppose example is that we are asked to calculate that how many moles are present in 90 grams of water. In this case, the given mass, which is denoted by M, is equal to 90 grams. The molar mass of water capital M is equal to 2 plus 16, 18 gram per mole, and the number of moles N is equal to small m by capital M, 90 by 18 is equal to 5 moles. So if we are given the mass of any substance, we divide it by molar mass and we get the number of moles. The second method, second equation which is used is equal to number of moles is equal to number of particles divided by Avogadro's number. If we are given the particles and we want to convert them into moles, we will use this equation. Let us suppose we are asked that what will be the number of moles of oxygen, what will be the number of moles of a sample of oxygen containing 10 to the power 1000 molecules. So the number of particles are 1000 and the number of moles will be given by the formula 1000 are 10 to the power 3, number of particles are 10 to the power 3 divided by Avogadro number 6.022 10 to the power 23, we get 10 to the power 3 minus 23 divided by 6.022, 1 by 6.022 10 to the power minus 20, or we get, if we approximate it, we get 1 by 6 into 10 to the power minus 20, or 0.166 into 10 to the power minus 20, or 1.66 into 10 to the power minus 21 moles. The last equation which is used is that one. If we are given the volume of a gas at standard temperature and pressure, then we can calculate its number of moles by the third relation. The third equation is that number of moles of a gas is equal to volume of gas, given volume of gas at standard temperature and pressure at STP divided by molar volume. The molar volume is always fixed. Molar volume of gas at STP, and the volume occupied by 1 mole of a gas is called molar volume, and molar volume at STP is 22.4 decimeter cube. So we can calculate the number of moles. Now the question is the last point, that what is the significance of studying moles? There are two advantages of studying the mole concept. First advantage is that if we know the number of particles, we can calculate their mass or volume. And second, if we know mass or volume, we can calculate the number of particles. And number 3, it is helpful in determining the molar mass, calculating or determining the molecular weight or molar mass. End of this topic for today. Allah Hafiz.